Welcome. Today I want to introduce you to NATS. NATS, think of it like WhatsApp but for computer programs. So first off, NATS gives you simple publish and subscribe, and let's provision a NATS server on Kubernetes. I have a local Kubernetes cluster which I will deploy NATS to now. Okay, service created, NATS created. Let's see what we have created. Let's get the pods. So NATS box is a command line utility. It's running inside Kubernetes, which will connect to three NATS servers, NATS, NATS2 and NATS3, and these three NATS servers are running in a cluster. So let's set up our interaction screen. Okay, let's copy that into here. Nope, that's not what I wanted to do. Run that. Actually, I should just do this first. Run that, and the last one. Use this instance. There are two NATS instances anyway. Okay, so we now have three NATS box instances spread over two pods connecting, well, about to connect to NATS servers. So anyway, if you want to follow along, that's the GitHub repository with the code to bring up Kubernetes and stuff like that. Right, so think of publishing as broadcasting to a radio channel, and I'm going to create test.x radio channel, and NATS does this creation on the fly. So that's the command to publish to test.x. So I'm going to publish it here, and it's published 2 bytes x1. Now let's tune in. So that was published using the NATS, the main NATS server. Well, they're all in a cluster, so they're all equal. But I'm going to connect to NATS2 now. NATS2 is here. And I'm going to subscribe. I didn't receive anything. Why not? Well, I just turned on my radio and I tuned in just now, but that message had already gone by, so it's lost. So let's tune to another kind of channel. This one is a super channel that listens to all of tests. So this is on NATS3 server, and I'm going to subscribe to test. That greater sign says everything underneath tests. So now I've got two subscriptions running. Let's publish x2. Now x2 is received, and here and here. But if I publish dot y xy3, this receives it because it receives everything under x, but not this one. Right. So NATS delivers messages, traditional NATS standard NATS. Delivers messages at once most. It's a typical philosophy class quotation. If a tree falls in a forest and no one is around, well, does it matter? Same with NATS. If we publish on NATS and no one subscribes, the messages goes poof. Can NATS do better? Of course it can. All we need to do is enable Jetstream, and it can keep track of messages. So I like Docker, I like Kubernetes. Let's run this. I'll clear this. So Docker run NATS, it's version 2.2.5 now. And to enable Jetstream, all you do is that. And Jetstream is running. So you can store 66.5 gigabytes worth of stuff for my instance. Control C and it stops. Right. So now the NATS cluster, the three of them are in a high availability redundant cluster, already has Jetstream enabled. So let's record our messages into a stream. I like to think of a stream as a log file. And the first thing I'll do is create a stream named TST, short for test, but I want to differentiate it from TEST. Now, this stream in NATS has some rather interesting properties. Let me tell you. Let me show you. Let's clear that. So I'm going to connect to the main, well, a NATS server in the cluster, and I'm going to add a stream. The stream is called TST. The subject to consume will be test everything under test. I can keep it in memory, or I can keep it in file storage, or keep it in file storage. So messages are either based on limits like size or age, or if it's on interest, if they are consumers, which we'll talk about in a while, or if they are workers processing them. So I like to keep them for a long time, so I'll use limits. If the limits are exceeded, what do you throw away? New messages or old messages? I like to throw away all the old messages. So what are the stream limits? How much you want to keep? Unlimited. Alright, as much as my storage permits. How much you want to store? I can store 1 gigabyte, 10 gigabytes, 1 terabyte, as much as my storage permits. How long do I want to keep the messages for? Oh, this is interesting. I can keep them forever. I can keep them for a certain number of seconds, minutes, hours, years, months, days. I'll keep them forever. How big should that individual message be? Well, typically NATS limits you to 1 megabyte messages, but as big as I configure NATS to be. This one is really interesting. NATS with Jetstream is at least once, but within a window of here 2 minutes, it can guarantee exactly once. This is nice. It can't guarantee exactly once forever, but it can guarantee exactly once for hours or months or days. So this is useful in certain circumstances. I'll leave it at 2 minutes, which is the default. Replicas is also interesting. I've got a 3-node cluster. The default is 1, but my event messages are precious to me. So I want to keep 3 copies of them and spread it around the cluster. So now I've got a cluster. The leader is NATS3. It doesn't have to be NATS. There are 2 replicas. There are no messages right now. Let's look up. So these are the things we configured, and it was created just now. Right, so we can get the info again using this command. It's exactly the command you saw just now, nothing too interesting. Let's go and publish. So I'm going to publish to test.x, x1 again. And I publish 2 bytes. It's received here, it's received here. Good. Here's a really interesting thing. I published it. Now it's recorded. Test.x received at this time, and that was the message that was received, and nothing else was received. Let's publish something else. I'm going to publish test x.y, xy2. Okay, this one should show up at the bottom right, and it does. This one doesn't show up. If I view it now, 2 messages. It's recorded it. Now publish is fire and forget. I want to make sure that when I publish a message, the server responds. I can ensure that with this command. So instead of pub, I use a request. And now x3 is received on the subscribers as usual. But you can see the server has acknowledged received on this particular inbox, and it took 1.4 milliseconds to get to the server and back. And if I view, there are now 3 messages. We have now logged events into a stream. How do we consume this stream? I'm going to create 2 consumers. One that is only interested in test.x, and the other consumer is interested in all of tests. So let's add a consumer. So the consumer is called, the first one is only interested in X, so I'll call it X. It's going to be a pull consumer. We'll talk about pull consumers and push consumers, but pull is the most useful for me. What messages is it interested in consuming? So it can start from the very beginning, all, or just the new messages, or repeat the last message, or repeat the last 1 hour, or 1 day, or 30 minutes, or last month, or from message sequence number 2. I'm interested in all messages. How quickly should I deliver these messages? As fast as possible, of course, or I can deliver at the original pace, right? Well, as fast as possible. This consumer is interested only in test.x, so I'm going to filter the stream, so non-interesting messages won't come to this consumer. What's the maximum about deliveries? Well, all unlimited attempts. I want to make sure that it's acknowledged first before the next is the safest. And the stream as TST. So I've now established a consumer, and there are 2 unprocessed messages. I'm going to do the same thing again very quickly for the all consumer. So pull, all, instant. I'm going to leave it blank, get everything. These are the default tests. This one has 3 because there was 1 XY in there, remember? So this XY2. Right. So how do we consume messages? This is how we consume. This is how we pull messages. So I'm interested in X only here. That's X1. And remember, that's X3 and nothing else. Okay, because the second message was XY2, and now it's waiting for messages to come. How about this one? Let's cancel that off. I should get 3 messages. The first message, the XY message, and the third message, and not waits. Let's publish something else. Let's call it X4. Now it's waiting, it's long polling. If I publish or request to publish X4, boom, messages gets across immediately and it's acknowledged. So I know it reached the server and it was persisted. So what are the other things we can do with streams? Well, we can do interesting things like stream report. Yeah, there's a short form str, you have to type out the full name. You've got 4 messages in there because we just created X4. We can view all the messages in test, 3 messages at a time, because my screen is rather small. So that's the first 3 messages. Next page, we've got X4. Yeah, got it. This is very useful for GDPR. The XY message is, let's say, has to be removed because of GDPR or PDPA in Singapore, whatever. So I'm going to remove message number 2, this message over here, from the test stream. Really want to remove it? Yes, it's gone. Let's view it. Now only have 1, 3, and 4. The XY is gone. Nothing else in the next page. What can we do with consumers? Well, I can list the consumers. I've got 2 consumers. I can do something interesting here. I can copy the test all consumer to the all one consumer. And now all one has 3 unprocessed messages. Let's go down here and go and consume those 3 messages. First message X1, the X2, XY has been deleted, so it's X3, X4, and now your block. And finally, we can go and purge all the messages in test. All the messages are gone now. So 3 consumers listening to it, but no messages now. 0 messages. And finally, I can remove the stream itself. Really want to delete? Yes, let's clean up. And I can clean up from Kubernetes as well. Gone. So there we are, a quick crash course in NATS. So again, if you want the presentation source code as well as the code to spin up stuff in Kubernetes, it's here. Thank you. My name is Yu Yin. I work for Zendit, and that's my email address.